Erection of primary and secondary structural assemblies. To begin the structural assembly, the interior frames nearest the end wall are usually erected first. The proper plumbing of these frames is extremely important to the successful completion of the building. Raising rigid frames. Although several methods are used to erect rigid frames, it has been found most satisfactory to stand the columns first, tie them together with the girts, and then tighten the anchor bolts. The anchor bolt tension may need to be adjusted later when you seat the rafter. On small spans and short eave heights, columns can often be set in place without the use of hoisting equipment. After the columns have been erected, the first rafter should be ground assembled, hoisted into place, and connected to the columns. Generally, as many connections as possible are made on the ground prior to the rafter being lifted into place. The size of the rafter which can be safely handled depends by and large on the equipment available and the experience of the erection crew. The hoisting equipment should never be released from the rafter until the frame is adequately braced, so it cannot buckle or tip. Erecting cold form end wall. Prepare the end wall columns for erection by first installing the girt clips. Confirm the direction and placement of these clips by consulting the erection drawings. For ease of erection, all end wall columns have a universal punch pattern, making clip placement repetitive. Once the correct clip location and direction for a particular column is determined, all cold-formed corner columns can be clipped the same. All cold-formed door jambs can be clipped the same, and all interior cold-formed columns can be clipped the same. This will save considerable time and effort as the end wall is framed. Stand the columns one at a time, paying attention to the location and direction they're facing. The open face of all corner columns will face the center of the building. The open face of all interior columns and door jambs should face away from the center of the building. Consult the erection drawings for location and direction. Tighten the anchor bolts and base clip bolts. All end wall rafter, purlin, girt, and eave strut connection bolts should initially be hand tightened. This allows the entire framework to be plumbed without undue difficulty. Raise and attach the rafters using the bolts and center connection plate as specified in the erection drawings. The end wall should never be left standing for any length of time without proper bracing. When this frame has been set plumbed and braced, Mueller recommends that all purlins, girts, and eave struts be installed in the bay. To a large degree, the remaining structural members will automatically plumb and align when installed. All end wall girts and door headers may now be installed. Raise and attach the eave struts specified in drawings. All roof purlins may now be installed as specified. There are two things to keep in mind when installing the purlins. First, purlins have a slightly wider edge and a narrower edge to facilitate nesting together at the overlap point. Install the wider edge of your first length of purlin on the bottom. That way, when you install the continuing length of purlin with the narrow edge on the bottom, they will nest correctly where they overlap. Second, note that a purlin or girt lap will have 2 bolts at the rafter clip and 2 bolts on each end of the lap for a total of 6 at each lap. There could also be a fin head bolt covered by the nesting purlin holding the first purlin in place, making a total of 7 bolts. By design, this leaves one open hole at the rafter clip to aid in spudding the lap together as necessary. Install all anti-roll clips and flange braces as specified in the drawings. This will stabilize the frame significantly. Plumb, square, and level the end wall with temporary bracing. Tighten all bolts. After the entire bay has been assembled, only a final check of the building plumb remains, and a few adjustments, if any, will be necessary. During erection, temporary bracing is required. Never leave a building overnight without proper bracing. Erecting the remaining frames. The remaining frames are erected in like manner, initially with only a few purlins being installed in each bay, working from one end of the building to the other. To lend overall rigidity to the structure, install flange braces to the purlins at specified locations. All purlin, girt, and eave strut connection bolts should be hand tightened so the entire skeleton framework can be plumbed without undue difficulty. The remaining purlins can now be installed on the rafter members. Be sure to take precautions to secure the structure during assembly. Temporary bracing may be required to stabilize the structure during erection. Never leave the structure unbraced. An unbraced frame can easily be damaged by wind gusts. Diagonal wind bracing. Some buildings require permanent diagonal wind bracing. This provides support for wind loads or other longitudinal loads. The erector should review this requirement. On some smaller buildings, diagonal bracing is not needed for the building design, so the erector must furnish any temporary bracing needed. Check building plans to see the specific bracing requirements for your project. If required, the diagonal bracing is cable. It should always be installed as shown on the erection drawing that came with your building, and should be tensioned so that the building will not sway or rock when the wind blows. Care should be taken, however, not to over-tighten and bend the structural members. The workmen should watch the structural members carefully as they tighten the bracing. Bolt tension. Upon completion of the frame, and after the frame is plumb and square, all bolt connections should be tightened. Even those connections previously tightened should be checked, as they often loosen while the frame is pulled and pushed to completion. Base angle and rake angle. Once the structure of the building has been assembled, install the base angle around the edge of the slab. It is suggested that a hammer drill be used to drill holes the appropriate size in the slab at 36-inch intervals. Use drive pins to attach the base angle to the slab. Rake angle can now be installed on top of the purlins at the end wall as shown in the erection drawings.